And we are recording this meeting so that we can post it on our website later today for future reference. So as I said, today's presentation is focused on the automation of the design process with the goal of getting designs to market faster. There are 6 topics, as I mentioned, that our presenters are intended to demonstrate. Our presenters today are from AXISCADES. They're a business that is located in the United States and in India. Lax RK is a business manager from AXISCADES. He's responsible for client relationships in Canada, and he's currently based out of Montreal. He has over 15 years of diverse experience in aerospace and automotive engineering services. He's a mechanical engineer with honed skills in technical sales and marketing, strategic account management, new business development, and relationship management. Bharath Ganeshan is joining us from India. I should mention that Lax is joining us from Montreal. Bharath is an accomplished product development and technical manager with over 14 years of progressive experience in varied domains and leading technologies for digital transformation. He is currently associated with AXISCADES Technology and is responsible for delivery and project management of various key assignments. He's a proven track record of achieving significant improvements in profitability, productivity, quality, and customer satisfaction while reducing costs, improving turnover, and maintaining a positive work environment. We're also joined by Sudeep D'Souza, who has over 12 years experience as a solutions architect in digital transformation. He graduated with a bachelor's degree in mechanical engineering, holds an MBA in operations management, has worked in aerospace, automotive, industrial, consumer products, executing projects, and in mechanical and software applications. Sudeep has a proven track record of implementing high savings projects in robot process automation and artificial intelligence for productivity improvement. He now takes a lead as the solutions architect and consultant for companies who want to accelerate their digital transformation journey and manages the digital transformation team at AXISCADES. So because Lax is from Montreal and the Jets are playing Montreal tonight, I do have to end with this slide. And with that, I will pass it to Lax and the team at AXISCADES for the presentation.
Hey, thank you very much, Ron. I really appreciate that. Bonjour, hi, gentlemen and ladies. Though already Ron has introduced me, I'll still go with my introduction by myself. My name is Lakshmisha Rajara Kusmarao. You can call me Lax. I'm a relationship manager based out of Montreal, looking after the key relationships in Canada. So as he already mentioned, I'm a mechanical engineer by discipline, but slowly transitioned myself into a sales. It's not easy, but done that. Okay, and today what we'll do is I'm going to walk you through a little bit about AXISCADES. So I'll try to make you understand what in the nutshell AXISCADES do. And from there, I will pass it on to Bharath, who is going to talk about the intelligent automation. And from there, he's going to be passed it on to another of my colleague, Sudeep D'Souza. He's going to talk about the bots in engineering. So here, once again, I would like to take this opportunity for to thank Ron. Ron, thank you for giving us an opportunity to present this, and special mention of VTCI. So in the nutshell, a little bit brief about an AXISCADES as a company. AXISCADES is a multinational pure play engineering solutions company. When I say pure play engineering service company, the reason being is we are not another vertical of a software giant. We are purely focused on engineering. Any technology we develop, any automation we do, or any digitalization we do, it's always focused on the engineering because we understand and it's our DNA. And you can see how our business is happening, and 31% of the business is coming from the aerospace. Another 25% of the business comes from defense and homeland for us. The remaining 44%, which is once again predominantly occupied by the heavy engineering and a little bit of automotive and energy. When I say AXISCADES, it's a very big company, and it's a public listed company in NSE and BSE, and we are also a designated offset partner. It's called IOP, India Offset Partner. And you can see the website there. If you have, we're going to leave our contacts at the end of it. So whenever you have some questions or you want to see something that is specific to your key domain or your interest, so should you have any questions, feel free to reach out to me. We'll be more than happy to help you, and we will see how it goes from there. Sudeep, can you just move on to the next one? Yep. AXISCADES is a global company, though based out of India. The origin is from India. We have around 16 state-of-art engineering service centers around the globe, predominantly coming from North America and Europe, and focused in India. We also have our engineering centers in China, where we have engagements with heavy engineering as well as in aerospace OEM. We have around 2,000 plus engineers in AXISCADES, and yeah, so this is our global footprint. Yeah. So these are our business verticals. So we focus predominantly on aerospace, defense, heavy engineering, automotive, energy, and medical devices. When I say, these are the key verticals, so basically we have a pedigree of around close to 3 decades in each of the field. So we are top partners. We call ourselves the partners to the top OEMs, whether it is aerospace, automotive, or heavy engineering. So this is how we organize. Our services starts from the concept design till the manufacturing solutions and to aftermarket sales. Yeah. If you look at this, our service offerings, we start from the concept. When the concept is created, some idea is conceptualized, we jump in there with our partners, and from there we help them create the concept designs. From there we help them do the detailed designing. From there, we will help them to create the prototypes. We will help them to create the certification processes. We help them after the sales of the product. So this is how we are organized. We do the product engineering. We do the embedded and electronics. We do the system installation. We do engineering analysis and certification. We also help our partners in manufacturing engineering services, product sustenance, and after-sales product services. We have our units of digital services where we tailor the solutions for the engineering, and we also have our PLM and engineering IT implementation. So this is what is AXISCADES in the nutshell. And once again, thanks, Ron, for giving me this opportunity. From here, I'll pass it on to my colleague, Bharat. He will walk you through some very, very interesting and intelligent automation. Thank you, gentlemen. Thank you. Over to you, Bharat.
Yeah, thanks. Before I start, we'll just watch a small demo video of AXISCADES, and then I'll start.
We leverage technology for solutions in our known area, industrial enterprise. We provide solutions for agile industrial enterprise. We blend our engineering, manufacturing, and industrial enterprise knowledge with technology to help our customers apply digital capabilities to products, processes, and assets. Improve efficiency, enhance customer value, manage risk, innovate and discover new opportunities, enable insights across enterprise. We have organized our solutions into 6 horizontals. Connect devices, design industrial applications to view, monitor and control manufacturing operations, and seamlessly collect OT data in real time. We integrate ERP, PLM, SCADA, MES, CRM, and other enterprise applications to a data hub in a decoupled architecture with Kafka as highly available and redundant infrastructure. Industrial simulation. Virtually simulate production process and subsequently plant process before actual production to optimize the control system performance and operations efficiency, and in turn create a digital twin for production process plant. Enterprise PLM. Management of the product lifecycle data based on a product innovation platform. We develop web applications, desktop applications, and mobile applications, including native and progressive web applications. We automate mundane process using robotic process automation, RPA. Visualize, analyze data, and add predictive algorithms as desired with custom applications, and also use BOTs to list, tabulate, graph, and provide information from data with our data analytics solutions.
Yeah. Hi, good morning, good afternoon, and good evening to all the people who are part of the seminar, and special mention to Ron and VTCI for providing this opportunity. And my name is Bharat Ganeshan. I'm part of the digital transformation team at AXISCADES. So we primarily work on the automation and application development as a part of solutions and services offerings from the AXISCADES for various aerospace, automotive, heavy engineering, and embedded projects. So we leverage technology to develop solutions for agile industrial enterprises through 6 competencies by blending our engineering, manufacturing, and industrial enterprise knowledge with technology to help our customers in their digital journey. As you saw in the video, digital means different, or it is interpreted in a different way by different people. So I just want to cover up what the 6 competencies and what it means from the AXISCADES point of view. So the first one, the IIoT integration solution, it's a competency where we bring mobility to manufacturing and build on a universal platform to decouple devices and application to seamlessly collect data for the solutions which are flexible, agile, and scalable in nature. And industrial simulation, or I would rather call it production simulation, it ensures everything is production ready with real-time rendering of the CAD data for the plants, processes, and parts. With enterprise system integration, we connect all the data sources to one bus with Kafka as an infrastructure and build application on this. With enterprise PLM, we customize the platforms with the different functionality and introduce customization at various levels for upgradability. Data analytics and intelligent automation, basically to improve the productivity, optimizing the processes for intelligent workforce, and use data analytics to gain insights for saving cost and time. And my colleague Sudeep has got a lot of use cases during the entire seminar, mainly which shows on these platform. And finally, the application development, where we also build kind of custom software applications which are tailored to your story, and they're scalable across multiple devices and types for secured user experience. So with this, I'll just hand over to Sudeep on to talk on the intelligent automation for the part, and then we'll continue with the use case studies. Over to you, Sudeep.
Yeah, thank you, Bharat. So one of the sections that we have within AXISCADES as a whole and under our digital solutions is intelligent automation. So in intelligent automation, what we do is we strive to build what we call the intelligent automated workforce. So we use computer vision data, that's data which you normally collect, but as well as big data processing, natural language processing, the human to machine interface, because humans is also sometimes part of the loop when it comes to building the intelligent automated workforce, and robotic process automation. Taking data from all of these, robotic process automation could also be an input as well as an output. So taking all of this into account, combining that data that we collect together from sound, from sense, from touch, from feel, from speech, that's the natural language processing part of it, and from humans as well. Combining all of this information together along with machine learning and deep learning as the decision maker in this entire process, we build what we call the intelligent automated workforce. So it isn't just robotic process automation that does the input and output, which you need to teach step by step to go through your process flow in order to replicate what we do as human beings onto a computer, but also combine it with machine learning and deep learning in order to make those decisions. This increases the power of RPA 10 to 20 to 100 fold and makes productivity much, much, much more faster. In that sense, when we help out customers or when we go and talk to our clients, we present to them a maturity model. Now, we would have all heard of the CMMI, right? But even in the transition of digital transformation, we actually head towards doing things as human beings on a low scale, as in most of the work that we do is on a computer, is all done by human beings, to moving upscale, doing scripting, doing assistive bots, doing robotic bots, and doing autonomous bots. So this entire process flow, we use the power of intelligent automation, and we are hoping that we can help you also to leverage that power of intelligent automation in order to improve productivity, increase speed, and increase in time to market. So going across this transformation maturity model, we do macros, right? We do SAP, we do GUI. So things like that fall under basic scripts. We have attended bots. Now, attended bots are things that we do as person with human beings that can help us to make our work faster. And we then go to the robotic process automation approach, where we do integrated automation, where we tailor make the processes to have automation first and then offshore the remaining creative work to human beings to do. So the repetitive work is always done by a computer. The creative work is done by a human being. And then we move towards the autonomous process, where we actually have most of the work, even decisions based on data, done by robots. So Bharat can take you through automated drawing creation that we've done for some of our customers that helps to convert 3D models in order to 3D models. Over to you, Bharat.
Yeah. So this is the first case that we want to present in the today's seminar, which is automated drawing creation. And this was done for one of our aerospace client. When we received the drawing creation package for a particular aircraft program, this part is basically a composite part, which is known as a stringer. These are basically a longitudinal members of an aircraft, which are present in several hundreds of numbers throughout the aircraft per aircraft. And there'll be a small deviations in their dimensions, and apart from that, they vary from the medium to complex geometry structure. But most of the time, it's similar in terms of it's similar in terms of shape and form, etc. So when we received this package to create the drawing creation with all the kind of information that are to be presented in the sheet 1 and sheet 2, typically a drafter or an engineer would take around 4 to 6 hours for the completion, with all the instructions, standards, the views, and all to make it more manufacturing relatable drawing. Okay, so when we started creating when we received this package, can you pause it, Sudeep, please? Yeah. So when we receive this, so you can see the automatically generated. So let me move over here. So in the demo, what you're seeing is here is basically you have loaded the 3D models into the CATIA environment, and using the creative intelligence, what we have done is we have created through the VB scripts all the business logics that are required to perform step-by-step functionality. So what is done is it takes in the basic information at the background, once you're keying in and referencing the respective, and this part is a composite part, so there is some kind of a core sample table and other necessary informations are taken into consideration. Yeah, please go ahead. So once you key in the necessary information and reference the respective core sample tables over here, as I mentioned, so it creates some kind of a supporting planes, and it goes into the drawing sheets, and it starts creating the views automatically with all the information that is required with respect to the particular views, the dimensions, the notes, annotations, and it's now moved to the sheet 2 to create other sectional views and the tables of the core sample. Everything just within a minute. So this is the first use case that we have done where it is not only fast, but also it maintains the standard of creation. Yeah, can move to the second one, Sudeep. Yeah. So the first use case was on the drawing creation process. So now we have received a lot of drawings, automatically generated. And now the next bottleneck is going to be a quality check. Okay. So even though we have created the drawing in the first phase automatically, it is up to 60 to 70% automatically generated with all the maximum views, and still the user had to spend some time to do some kind of aesthetic changes. So after that, still somebody has to check all these drawings which we have received. So what we did is the second use case for us was to create a quality check macro, which will essentially do the quality check using a checklist, how a QC person would do that. And we understood the entire process, how manually the person checks it, and we built a business logic behind it, so that the drawing quality check is happening when engineer or drafter starts the process. You can go to the demo. Yeah. Yeah, so here you are seeing the the user is invoking the macro within the CATIA environment, and he's checking in all the necessary information that is required for this quality check. And the macro is now interacting with Windchill, which is our CAD data management software for this particular program. So it is now going back, and you can see the progress happening at the back end, where it has done all the necessary checks, and then it generates a report with all the status here in a color coding, and also the remarks where the drafter or the checker has to concentrate on correcting those information. These are essential informations, and even like as I mentioned, like basic FIR, like your fundamental information details and all the readability informations are present within the drawing. So the user always has a flexibility to go and fix back those necessary things, which saves his time, as well as digitally he can store this document for any of the future reference purposes. In case if any of the comments have to be overlooked, can also be done over here. So this is the flexibility that has been built for the drawing quality check macro. Yeah. And another useful and interesting case study we have, this is again in the drawing comparison macro, not the macro, it's I would call it as a bot, okay, which basically works. The previous one you saw it inside a CAD environment, where it was running the macro and doing all the necessary checks. But over here we have you can use any kind of a CAD neutral formats, like your DXF or your STL or IGS, etc. And the user loads basically the two revisions. You're seeing here a version A and a version B, where you have your latest revisions and the oldest revisions being present here. And you run this option, and it also compares and checks for all kind of dimensions, notes, and other textual informations which are added or removed, and it highlights in a different colors, and a report is provided for the same. So we'll have just a quick demo for the same. Yeah.
Right. So over here, what we've done is we've actually used this to build both a desktop application as well as a web-based application. So what I'm showing you over here is the desktop application. On the screen over here, what I request you to do is quickly see if you can spot the differences. Now, these are two different versions of drawings, and the previous case study that Bharat showed was process checks, which means it checks the drawing dimensions, the drawing tables, the size of the font, etc. But there are drawing checks that you need to do in order to do a comparison to see how has the drawing changed between different versions. Drawing is mostly dimensions, so identifying those dimension changes allow us to identify the drawing changes. So in this case, what I'm going to do is select two drawings of different changes and say compare. So what this does is it goes through those drawings, figures out where all the dimensions are, does a comparison between both of them, and then gives us an output image highlighting the differences on both those drawings. So if you look over here, this is one of the drawings that I've selected. This is the other one. And if I zoom in, you can actually clearly see that it becomes very easy for a person who's doing quality checks on the drawings to figure out what has changed. So quickly, this has now got a 58 to 52. Those dimensions are not there in this drawing. There's a 50 dimension, which is a diameter dimension that's not there in this one. The 606 is not there over here. The 505 is there. So all the red points that you have over here, those are the dimensions that are missing from this one. The drawings, the red points over here, those are the dimensions that are missing from this one or changed, right? So that way it becomes very easy for a person who's doing a comparison check to actually figure out what has changed between drawings. Another key study that we've done is after we've moved now from generation of drawings, we've moved to quality check or process quality check of drawings. We've then done the dimension comparison between drawings. The next step of this entire process of moving from design to your shop floor is figuring out which operations need to be done from the drawings and carry those forward into routing that needs to be created onto the shop floor. For example, take this as an example. This is a raw material part or a raw material sheet steel part that needs to be completed into a finished part. And that has to go through multiple stages on the shop floor. The first thing it needs to go is cut out either on a laser or on a plasma. Then you need to do in the bending operation, and then you need to do the drilling operation in order to get those holes, right? So as you move across these stages, the one thing that you need to do is store this information into some system, a PLM system or any system that needs to, that has information that needs to go to the shop floor on what operation sequence needs to be done on the sheet metal to get it into the finished part. So this quick example actually says your laser is your sequence 10, your press brake or your bending is sequence 2, your drilling is your sequence 3, and so on and so forth, right? And then that actually gives you what the finished part is. Having to do this manually is quite a lot of work. For a lot of drawings, people have to open them up, open each drawing up, show them, figure out how many bends, what the thickness is, what the material is, compute your standard cutting time, et cetera, in order to push it into JD Edwards, what the material is. So there could be a lot of materials. It could be sheet steel, it could be a tread plate, it could be a C channel, it could be an L channel, it could be a bar sheet. So figuring out what type of raw material, which features to extract, how do you convert them, all of this normally is being done by a human. We automated the entire process. So let me quickly take you through a video on that. In this process, like I said, what we did is we automated this entire thing. We built a bot with an easy to use graphic user interface. You can run it off a batch of parts. You can run it off a single part. You can run it off a single NIR sheet, which contains a batch of parts, or multiple sheets as well. So once we go through this entire method of configuring the tool, we can then easily, what the bot does is it picks up automatically all of this information. It automatically picks up the raw materials. It picks up the features. We've done it for Creo. We've done it for AutoCAD. So that's Creo is on a 3D model. AutoCAD is on a 2D drawing. And we've done it for both of them. So using that technology that we've built, it does the entire picking up of the raw materials, the picking up the number of holes, picking up the bends, picking up the profile cut, determining what type of part it is. It basically automates the download from Windchill, evaluates those parts, figures out the extraction of the data, as you can see that it's doing, and builds this entire routing information. So in some cases, it even asks the user if it cannot figure it out. The tool asks the user, okay, I don't know this information. What should it be? Or I found discrepancies in this information between what you have on the drawing, what you have already in JD Edwards, or whatever your PLM system is. So this section gives us the computed routing of what the system or the application thinks it should be. This is what exists in JD routing if you want to make a change. And you can actually then choose what routing you want to put into JD Edwards or whatever your PLM system is. And it now uses robotic process automation to write that information back into JD Edwards. So as you can see over here, it's signing into JDE, and then it can put all the required information back into JD Edwards. So automating this process end to end, right from the selection, or all the user needs to do is upload an Excel file. The system takes care of the rest. It downloads the parts from Windchill. It figures out the raw materials. It figures out the features that there are on the part. It then also uses robotic process automation to upload those parts routing. It also calculates the runtimes, the standard runtimes, and then uploads all that information back into JD Edwards. This amount of time saving and is much, much faster. For a user, it would probably take an hour to do for about a part in order to do the downloads, the checking, and everything. Our system probably gets it done in less than 5 to 10 minutes. So overall, that is what we do. We use technology to save time. We also have, after getting some of that information, and in order to do the maintenance of platforms or PLM systems, in a lot of cases, we kind of need to evaluate them or need to run robots and upload or download data from PLM systems. In that sense, also, we've helped our customers. So we've written bots in order to upload data and download data into PLM systems. So in this particular case, we've actually got a robot that we've written, which is primarily robotic process automation. There's no intelligence built into this one, but you can see the amount of time it saves. So in this case, you actually need to upload variant information into the PTC Windchill system. And what we're doing over here is just that. We've completely automated this process in order to upload data into Windchill. So as you can see, this whole information automatically gets uploaded into the Windchill system, and it does it really fast. So all of the selections being made, all of the items that need to be selected, everything happens automatically. Even in some cases like this, because what happens is these are Java-based interfaces, and Java-based interfaces are normally extremely difficult to build RPA bots on. But we've even gone to the extent of automating Java-based interfaces using a combination of mouse clicks and optical character recognition. So that whole stance and the overall time savings that get impacted, or the increase in productivity that we have doing building robots like these for our customers, really, really improves productivity. And more than that, it's even more efficient to be done by a computer, because human beings over time tend to make mistakes. Lethargy sets in. Computers are not affected by lethargy. And because of that, they keep repeating the actions and over and over and over again, increasingly efficiently. So once we have all that information, let's then take a dive into the shop floor. So one of the other interesting projects that we've done for one of our customers is visual inspection. We've done visual inspection on drawings, right? Drawings are digital data. But how do you do that on physical products? Physical products are what we do after we've completed the drawing stage and we've produced those products. Now, in this case, there are two frames, right? The frame on the left is the frame that is actually the true frame, or what we call as the gold standard, because it's got all the information on it. It's easier to visualize this on two different images. The one on the left has the boss missing. So when I'm talking about bosses, I'm talking about these protrusions out here. These bosses are the ones that have harnesses or piping routed around them. In order to get them easily installed, these harnesses get routed over these bosses so that they just sit neatly in the final assembly. So if one of these are missing by accident, and all of these assemblies are done by people, so it is quite possible for a person to miss out on welding these bosses onto the frames. So say, for example, some of these bosses get missed out. In this case, can you identify which boss got missed out? You can see that there is one over here. near the number 35, and that one is missing in this picture. So that's the missing boss. Now, having this type of an inspection, a visual inspection done by a human being is also tricky, because he now has to go through a checklist saying, okay, X, Y coordinate, Z coordinate, there is a boss. X, Y coordinate, there is a boss over here. Which boss is it there? Did the ceramics still there on the boss? Because once you weld it, you've got to remove the ceramics. So all of that information also needs to be captured. And having that done by a human being over time, the assembler can make a mistake, the QC guy can make a mistake, and that can also go into production, right? But in order to solve this problem, in order to make it easier for the person who's doing QC, what we've done is we've built a robot to do that. So what we do is we have cameras that are situated on the shop floor that capture images at the final assembly point, where these, after the welding has happened, and then we pass this through a robot. So let me show you that bot. In this case, I'm showing you pictures because it's easier to do so. So there are two pictures over here. Those are the same ones that I've actually shown you on the slide, right? I'm passing that through the bot. What it does is it takes each of the images, and because these images are not aligned, they're from two different locations, they're from two different photographs, and because they're from two different photographs, we realign them so that they can actually sit correctly on top of each other. Now, the information can either come from an image, the truth information can either come from an image, or the truth information can also come from a drawing. The truth information can come from a model as well. So in this case, I'm using images just because it's easier for us to visualize. What we did is we built a deep learning trained convolution neural network model in order to detect where these bosses lie on each of the images, overlap the images, determine where the bosses lie, and determine which ones are missing. So in this case, you can see that it has highlighted all the bosses that are there in green, comparing it to this image. And this is the area that it has found where the image, the boss is not there. And as you can see, it has realigned the image so that it sits correctly. You see these fixture points on green that I've highlighted. So it uses those green points, realigns the image to where it is, and then there's where the bosses are, and overlaps those two images together to find out where the missing boss lies. And that's the type of technology that we're talking about. What we're doing is using technology to make people's lives easier and make human beings more productive using technology. All right. So in that whole frame of things, we also, once we're on the shop floor, we need to do time studies in some cases. So we do time studies because we need to actually find out where and how to improve productivity. Like I said, the whole intent of what we do is to help people improve productivity. And in that whole vein of things, we've built a time measurement system. You get time measurement systems in the market like Time Study Pro, but most of them are not customizable for people's needs. And we build this so that we get access or we get control over that code, and we can now build these type of applications to meet the needs of our end customers. So in this case, what we do is we just open a video. I put it on mute because this video is a bit noisy. So what we do is look through the video, and you can see the clock running over here. The clock actually determines where we start and stop these videos, so we can pause it, choose our required value add. In this case, it's going to be inspection, and then he's measuring. We can put the assembly number, we can put the station number, we can choose which operator who's doing the work is, and a lot of other configurable items over here. We can choose the parts. We can even do ergonomics, because sometimes ergonomics is important. So we can do ergonomics to identify whether it is high left shoulder, right shoulder, determine the ergonomics, and then put notes in and add activities. So even once we do all of this, the whole thing actually generates out to an Excel file with reports. So what we've got is also a system that we can use to help improve productivity even by doing time studies. Yeah. Okay. So that's an entire set of quick demos that I've showed you that we as AXISCADES do to help improve productivity using robotic process automation and artificial intelligence with machine learning to make decisions like you've seen on our shop floor detection robot, which uses computer vision in order to help improve productivity, right? Now, once we have all that data, we take data, we collect data in several cases. But how do we generate reports? How do we interface with that data? How do we interact with that data set? In most of the cases, it requires specialized teams of people who know query languages, you need to know software in order to interact and build those reports. You need people who know business intelligence software like Tableau or Power BI. So in order to help business users, what we've done is we've built a chatbot. This is a custom chatbot that we've built, which you can ask questions to the system in order to allow it to give you those answers. For example, hello. So I've also built this because I'm actually using Zoom right now in order to share my screen and talk. The microphone won't work because I can only capture one voice audio at a time. But I've also integrated a microphone so you can not only type your questions, but also ask your questions through voice. That helps with the NLP part of our decision-making capabilities. We do voice to speech to text and then use text using the natural language processing engine in order to convert that information to a chatbot. So in this case, I can ask questions like, give me the count of concessions, right? There are 2,508 concessions. Those are the number ones concessions in my database. But if I want to reduce on time in say 2020, in the year 2020, right? There are 11,028 concessions in the year 2020. Or if I even want, say, in July 2020, right? It gives me very restricted information. So I can not just to ask for count also. So if I want, give me the count of concessions, let's say for or by plant, it gives me that concessions by plant. I can also do plant in 2020 or by plant by program. And it gives me that count of concessions. So it's easy to do business intelligence, business logic types of questions like this. I can also ask it for, show me the graph of concessions in 2020, for example, right? And it gives me the graph of concessions over time, right? So if I say by month or add in a little extra querying and I say, I want this information by month and I want it segmented on a monthly frequency, it gives me data on a monthly frequency, right? If I say by month by plant, I can actually get even more segmented data by month by plant. I can even get a heat map. Heat map of concessions by plant by aircraft, say. Because this was done for an aircraft customer. The aircrafts are coded, of course, but you can see the heat map that it gives you by plant by aircraft. So this is the plants, this is the aircraft. So I can also say by plant by program, and you get a count of a heat map as to how the number of concessions are by plant by program. Or I can do it by plant by defect, for example, right? This is really long. So let's just do defect by plant so I can shift axis. So overall, you can actually see that it becomes very, very easy to by plant. I actually gave it by plant by defect. So it kind of gave me a overall. So as you can see, it gives me by plant by defect. And it's very, very easy now for a normal person or a business user to interact with your data in order to use natural language, use a chatbot to get business related information, get business related data, and present it in a form that's easily used by people. I can even do which month had the highest number of concessions in 2020, right? So it'll also give me this type of data. So this is the month that I had the highest concessions in the month of November, or I can say which plant had the highest number of concessions, or which defect, right? So it actually now gives me which defect has the largest, so is the geometry deviating, has the largest number of concessions, right? So this type of querying and this type of interaction with databases kind of makes it extremely easy for people to use in order to build reports or give information out to users. So that being said, we've kind of covered a lot of case studies over the last 30 minutes of the capabilities that we have to help use technology to improve productivity. And that's not all. We also build products. So we've got our own line of products in the COVID time. In our current scenario, we try and help people using our products like the WeCare EST and the People Counter. So the WeCare EST is an in-house built product completely run from scratch, right from your electronics to the software, to the casing, to the web application, to the mobile application. It integrates everything together into an easy thermal screening system, which can be installed on any door, anywhere that you actually have to do thermal screening. So either it's for shops or for organizations. All a person needs to do is go show the fist underneath it. It reads the temperature, records it, and you can generate a lot of information from there. How many people have entered, what their temperature is. You can store their temperature. We've built in both an anonymous method of screening where we don't capture people's information, and a required where people-based method of screening where you can either swipe your card on top of it, or you can enter your details on a phone app. The People Counter on the right-hand side that you have is helpful for shops and places that need to determine the number of people that are entering and exiting a closed location. So if you have a People Counter, it's a small device that you place in your doorpost. It uses a laser-based technology that counts the number of people entering and exiting, as well as the number of people already there in a location, and it gives alerts and alarms when there are too many people who are in a specified location. The Ecomox, which we have, is an asset health monitoring system that we've built for rotary assets. It's easy to install, just a box that you place over there, and it captures vibration information and electromagnetic flux, transfers that information. And based on the signatures that it reads, we've built an intelligent solution that any changes in those signatures get flagged. And you get provided with real-time alerts and possible actions that you can take. So overall, this is our entire intelligent automation solution set. Thank you very much for your time. We've done a lot of research in this area so that you don't have to. And if you need any more information, or if you are interested in the solutions that we have talked about, or any other solutions in the area of intelligent automation or engineering services space, please do get in touch with us for more information. Thank you very much for your time. Take care.
Thanks, Sudeep. Thanks, Bharat. Ron, over to you. And meanwhile, if anybody has any questions, can you please flag, and we'll do, Ron, over to you.
Yeah, no, thank you very much. Very interesting. My goodness, the things that you can do through an automated process, that's absolutely amazing. I've got one question myself just to start us off. Is I noticed like there's various CAD systems and business systems that are being used, right? There's, handfuls of business systems, obviously, but the predominant CAD systems being used here in Manitoba are Solid Edge, SolidWorks, AutoCAD Inventor. How transferable is a lot of the work that you've done? Like, let's say somebody wanted to do, engage with your company to do a revision check system, and they had a CAD system that you hadn't worked with before and a business system they hadn't worked with before. How difficult is it to adapt what you've done to these other systems?
It's not very difficult to do that because most of the CAD systems, let's take the CAD systems that we have. We've got CATIA, we've got SolidWorks by Dassault, we've got PTC Creo. On the other side, we've got Inventor, and we have Unigraphics. The commonality between most of these systems is that they use Visual Basic for applications as a customization platform. The difference is how we interact with each of those systems. Most of the code that we build is based on using Visual Basic for applications, or VBA, as a customization layer. And all we need to do is use the similar code base and swap out the interactions that happen between each of these CAD systems. So the logic remains the same, the interactions change. And that is not a difficult thing to do. In fact, it's actually pretty easy to just swap those out. And on the other hand, we've actually got a pretty good pool of resources who actually have worked with those multiple CAD systems. People who have worked with Inventor, people who have worked with AutoCAD, people who have worked with Creo. So they're specialized, or our people or our resources are specialized at doing CAD customization. And in that sense, it's not a very difficult thing to swap over from one, or the solutions that we're presenting, it's not difficult to swap over from one to the other. Also in that vein, some of our solutions that we have presented today are using CAD neutral formats. EXF, for example, is a CAD neutral format. You can export a DXF file almost in any software out there. And using that DXF file in a CAD neutral format, your whatever base layer of whatever CAD package you're using doesn't matter. It's CAD agnostic.
Well, that's excellent. That's excellent. I have a question here from Gagan Deep, and he's asking, and I think this refers specifically to the BOSS inspection, the digital inspection through photography. Will this inspect only if a feature is missing, or will it check for location as well and give the information whether some of the features are off where they should be?
Okay, that's a good question. So we are doing two things over here. One of them is we're measuring them on the X and Y axis. It doesn't necessarily have to be if it's missing. The part that we built is because it's missing is actually a more difficult thing to do. But if we have data as where it's supposed to be, and even if it is off, we measure the distances between there, and we can tell you if it's off or not. So in this case, I can, what I've done is highlighted the red area, but I can also do things with another yellow highlight in order to determine whether I've got an incorrect part installed. So they're now currently also working with 3D data. So what we're doing is a picture, right? A comparison using a RGB picture, but we're also doing a new project that we're trying to work with the Intel RealSense camera or depth cameras to get 3D information. Once we get 3D information, we not only have XY axis information, we have XYZ axis information. So we can compare it to not just the drawing, but also to a model, overlap a model onto your physical part in using augmented reality. And then on that, tell you what is different.
Okay,
that's the next level of shop floor inspection that we're working on right now.
Okay, that's great. That's great. So let's say a company has something that, a process that they want to automate. Like, for instance, let's take the bot for instance, there's a bunch of information in a business system, and they like this idea of the bot that you guys have developed. What's the process that they would work through with a company like yours to figure out, number one, if it can be done, number two, how much of it could be done, and number three, what the cost of it is going to be, to give them some level of surety and comfort going into it that it's going to work? What's the process that your company goes through when engaging with a company on something like this?
Okay. Lakshmi sir, do you want to take that one?
That Ron, it always depends from the based on the need and how do we take it forward. See, the first thing first, whoever is interested, they can always touch base with me, and we will have a technical round of discussion to understand the need. Based on this, we will give an estimate, and we will agree upon certain price point, and then we deliver the solution. So, but there are so many prerequisites before we get into that step. There is the NDA, there is a name contract that has to be signed, but all those things will be taken care. But there is a process in place. We also have a very well-defined process in AXISCADES for that. Anybody interested in taking this discussion forward, having something to get done, in terms of customizing or developing an application, please feel free to reach out to me. We'll take it from there.
Okay, that's great. That's great.
Yeah.
So, getting back to the missing boss example that you guys ran, how much, like, let's say that you had a assembly station that was manufacturing a certain component, and you wanted to run that component through a system similar to that, every component that comes out of that station similar to that. How long does that inspection take once you've got the baseline parameters of the truth, I think you mentioned, figured out, and once that digital photograph of the new one is taken, how long does that that comparison of dimensions and that sort of thing, how long would that take?
All right. In order to train a robot, in order to do this, we need to actually first collect data to identify what you need to inspect. The collection of data would depend on how our customer takes to, how long that customer or whoever needs to provide that data to us takes. The second step of that process is the training step. The training step is where we actually train our convolution neural network to identify the objects that need to be figured out. So on an average, that would probably take a week to 10 days because we need to fine tune the hyperparameters that actually go into training. So I know that you're asking me from an inspection standpoint, but once this whole process is done, at the end of the 10 days, we're left with a pretty accurate model that will give us information almost probably, and you should have seen that in the live demo, right? The demo that I showed you was actually live. So it took less than 30 seconds to identify where the bosses are and identify where that missing boss was. So you can do this on the training part of it, probably takes a bit more time than the inference part. The inference part is actually pretty quick. It takes less than 30 seconds to do it.
Well, that's interesting because as a human being doing an inspection, we're going to work from left to right, top to bottom, to inspect each of the individual features and make sure everything's there. Whereas if you do the digital comparison, it checks everything all at once, which is, seems to be a far surer process or better results in that process.
Correct.
Well, that's good.
It takes up a lot lesser time than a person would do it, because now since it's trained with that data, it has that model information. So either picking up pieces of objects. Now, in this case, it's only a boss, right? I've only shown you one boss, but it can go to probably 30 or 40 different types of objects in that image. Nuts, bolts, screws, welding, plates, any of those type of features we can use to train an object detector and use the same method to identify whether it is there, missing, or it's put in an incorrect location.
Okay. Very, very interesting. Very, very interesting. If there's any more questions, please feel free to use the Q&A feature, and we will bring it up. The one question I have, another question I have for you is, there's because our products are going digital, and a lot of our coaches, like for instance, transit buses, are controlled by programmable logic and technology. The idea of predicting failure of components such as alternators and other things. I'm looking at your Ecomox product, and could that be used in a mobile application? And the reason I'm asking is there's always been, when I was involved in the development of the first PLC bus at New Flyer, we came up with the idea that we may be able to predict the failure point of a light bulb in a bus and change it before it actually fails. Because if we monitored the current and the voltage, we may be able to see irregularities. And if we studied it enough, we would probably be able to create an algorithm that says that when this happens, send a message to the service department to change this bulb, even though it hasn't blown yet, because it's about to go. Could something like Ecomox be developed for we call it prognostics. Could something like Ecomox be used in a mobile application? Most
definitely. With the increase in the amount of data transfer on on the 4G network, using a phone or a mobile-based network, you can transfer data to almost anywhere. We also specialize in edge-based applications, so you no longer have to transfer that information into the cloud in order to have it processed. We can do edge-based applications, so your alerts come up on edge. So even if you are not in the network region, you can still get localized alerts from the system itself. Because we have edge-based solutions that you can use on an edge computing device. We generally deploy or do demos with a Raspberry Pi, because that's an easy-to-use development computing platform. But we've also done electronics-based projects without using our VKDST, for example, is a mobile-based, not exactly mobile-based system, but it is based on a similar technology. Okay, because yeah, we're looking for the same things. We're looking for irregularities in the amount of vibration, flux, and those sorts of things to determine whether or not these rotary components are going to fail. So, and yeah, so that would certainly be an interesting technology, even for inclusion on some of our products, which is really, really good. So with that, I don't see any other questions. So if you do have, if the people that are attending do have any questions, feel free to reach out to Lax, who can connect with Sudeep and Bharat and the rest of the team at AXISCADES. I wish to thank Lax and the team and Sudeep and Bharat, who joined us from India today. We thank you for sharing your evening with us, and we look forward to yeah, kind of walking into this new age of digital technology and understanding the things that it can possibly do for us to automate the mundane tasks that we do day after day after day that can be handled digitally. So we thank you for your time. Thank you for your input, and we wish you all a good day.
Thank you very much, Ron. It was a great webinar. I'm happy that our technical team was able to, and thank you, Sudeep and Bharat, once again. It was a wonderful session, and all the participants, thank you very much. Should you have any questions, please do not hesitate to reach out to me. Thank you.
All right. Have a good day.
Yeah, thank you.
Thanks all.
Have a good day. Ciao.
Thank you, man. Yeah.
Bye.
Bye.